Hello, I'm Simon Whistler, you're watching the Today I Found Out YouTube channel, and in the video today we're looking at setting fire to glass, the nope chemical that is chlorine trifluoride. First discovered back in the 1930s, chlorine trifluoride is a rather curious chemical that easily reacts, sometimes explosively, with just about every known substance on Earth. Just to get the ball rolling, here's a few of the more unusual things chlorine trifluoride is known to set fire to on contact: glass, sand, asbestos, rust, concrete, people, Pyrex, cloth, and the dreams of children. Obviously, the first question to answer here is how chlorine trifluoride is somehow able to cause asbestos, a substance that is known for being almost completely fire retardant, to catch fire. Well, that's because chlorine trifluoride is a more powerful oxidizing agent by mass than oxygen itself, meaning it's capable of rapidly oxidizing things that would normally be considered practically impossible to set aflame, like asbestos. Chlorine trifluoride is such an effective oxidizer that it can even potentially set fire to things that have seemingly already been burned up, like ash or spent charcoal. The substance is so highly reactive that famously unreactive elements like platinum, osmium, and iridium will begin to corrode when they come into contact with it. Notably tough elements like titanium and tungsten are also regarded as being wholly unsuitable to storing the chemical because they set on fire as soon as they come into contact with it. The only known way to store chlorine trifluoride safely, which we use in the loosest possible sense, is to put it inside of a sealed container made of steel, iron, nickel, or copper, which are able to contain the chemicals safely if they're first treated with fluorine gas. This is because doing so will coat the metal in a thin fluoride layer, which the chemical won't react to. However, if this layer is compromised in any way, or the metal isn't completely dry, chlorine trifluoride will begin to react violently and cause the vessel to explode. A few of the other things known not to react with chlorine trifluoride include liquid nitrogen, the inert gases, and polychlorotrifluoroethylene. Rather fortunately, chlorine trifluoride doesn't react with air unless it happens to contain a larger than average amount of water vapor. Speaking of which, when chlorine trifluoride comes into contact with water, it will react explosively with it, and as a fun byproduct, creates large amounts of dangerous gases such as hydrofluoric acid and hydrochloric acid. Hydrofluoric acid in particular is incredibly dangerous, and along with being able to melt things like glass and concrete, can permanently damage your lungs and eyes. As if that wasn't worrying enough, if you're ever unlucky enough to get hydrofluoric acid on your skin, it doesn't actually hurt until a few hours later. After it has absorbed a bit, it starts destroying your nerves and bones and can ultimately cause cardiac arrest when it gets into your bloodstream. In fact, in 1994, a lab technician in Australia accidentally spilled hydrofluoric acid on his lap, and despite immediately executing safety procedures, including hosing off, immersing himself in a swimming pool, and later extensive medical care, including needing to have one of his legs amputated, within 2 weeks of the accident, he was dead. Unsurprisingly, the Nazis were really interested in the military applications of chlorine trifluoride. After all, it's a substance that reacts explosively with water. Humans are largely bags of water, and for those that don't come into contact with it directly, there's the byproduct of the deadly gases. Further, there is really little one can do to put out the fires it causes directly other than to let them burn off. If you throw water on the source of the problem, it will get worse. The reaction here also doesn't require atmospheric oxygen to burn, so trying to use that method of fire suppression won't work either. Though chlorine trifluoride was thankfully never used during combat, the Nazis did succeed in creating several tons of the stuff in a secret facility known as the Falkenhagen bunker, before it was captured by the Russians in 1944. The Nazis working in the Falkenhagen bunker referred to chlorine trifluoride simply as Substance N, or N-Stoff, and were planning to store it inside specially designed shells which could be used in battle. According to reports released by the Soviets following World War II, Nazi trials involving Substance N were promising, but of course the weapon was incredibly dangerous for those carrying it around too, not just those they launch it at. As an example of the kind of devastation chlorine trifluoride can have, you need only to consider what happened when almost a ton of this stuff was accidentally spilled inside of a warehouse in the 1950s. According to eyewitness reports, the chemical burned straight through a foot of concrete and 3 feet of gravel, while simultaneously releasing a deadly cloud of gas containing a cocktail of chlorine trifluoride, hydrogen fluoride, chlorine, and hydrogen chloride that corroded every surface it came into contact with. After watching this video, you're probably wondering what possible purpose this chemical could serve that doesn't involve trying to recreate a scene from a Michael Bay movie. Well, due to the fact that chlorine trifluoride is such a great oxidizer, there have been several attempts to use it as a low-cost, lightweight rocket fuel, starting with the Nazis, who used it to propel torpedoes. Of course, it's so difficult to store safely that it's generally considered not to be worth the risk for this usage. After all, while you'd need to use less fuel thanks to its extreme oxidizing capabilities, if you had a rocket accident, you'd potentially be spewing tons of this stuff all over the place with no real effective way to deal with the situation. For instance, after studying and experimenting with this chemical for rocket use, rocket scientist Dr. John D. Clark famously said about the best way to deal with potential chlorine trifluoride rocket accidents. He said, "I've always recommended a good pair of running shoes." There are a couple of other useful applications though. For instance, it's great for plasmaless cleaning of certain surfaces used in semiconductor manufacturing, and it also works well at cleaning uranium residue off the walls of nuclear power plants and removing built-up oxides. So I really hope you found that video interesting. If you did, please do give us a thumbs up below this video, and don't forget to subscribe to our channel if you haven't already. Also, over there on the right are a couple of other videos you might enjoy if you enjoyed this one, and thank you for watching.